Okay, think about this. You probably did it this morning. Reach for that little metal or plastic tab, pulled it up, maybe down, and just like that, snap. Two pieces of fabric zipped together. Or apart. I mean, yeah, the zipper. Seems so simple, right? But have you ever stopped, really stopped, to think about how incredibly clever that little thing actually is? What sort of uh, thinking went into making it work so well? Why is it everywhere? Welcome to the deep dive. Today, we're not just, using technology. We are getting out the magnifying glass. We're looking at one specific, everyday marvel to the zipper and figuring out how it's designed, how it gets made, and how it keeps getting better. Our mission, to help you think like an engineer, like an innovator, just by looking really closely at one ordinary thing.
It really is fascinating, isn't it? So many things we just, well, take for granted. They're actually these little miniature triumphs of engineering. They solve problems we barely even notice anymore. And today, yeah, it's all about the zipper. We'll dig into how it works, why it matters so much, and hey, maybe even how we could improve it.
Okay, let's do it. Let's unpack this tiny titan of textiles. We picked the zipper because, yeah, it looks simple, but wow, the design thinking behind it, it's really something. I mean, jackets, jeans, backpacks, tents, you name it.
Right. And to really get it, you can't just glance at it. You need
Yeah.
to analyze it. Think about drawing it, labeling the parts. How do they all fit together?
Yeah.
Basically, you've got three key bits, two rows of teeth, right?
Yep.
Sometimes called scoops or attached to fabric tapes. And then the most important part, the slider, the thing that moves up and down.
The slider, yeah, that's the magic part.
It is, because it's basically a tiny, cleverly shaped wedge. So when you pull it up, the front part of this wedge, it pries the teeth apart. That's the unzipping. But then, as it keeps going, the back part of the wedge smoothly guides the teeth from both sides back together, and they interlock really strongly. Each tooth on one side has a little hook,
Mm-hmm.
and on the other side, a little hollow, perfectly shaped for that hook. It's like a tiny, perfectly repeating mechanical handshake.
Wow. Okay, and it's not just mechanics, right? There's science involved here too.
Oh, absolutely. You've got simple machine principles, sure, like leverage in the slider, but there's also the precise geometry. Those teeth have to be shaped just right to lock and unlock smoothly. And then there's material science. What kind of metal? What kind of plastic? Does it need to be strong, flexible, rust-proof?
Yeah, that makes sense.
Exactly. Think about the strength. It doesn't come from one single point. It's the fact that you have dozens, maybe hundreds, of these tiny little interlocking points working together.
Right, cumulative effect.
That's it. Strength in numbers. And choosing brass for, say, heavy workwear versus lightweight plastic for a kid's pencil case, that's a deliberate engineering choice based on function. It's a whole system.
Okay, so we've got the mechanics, the science, but why? What problem was this thing trying to solve in the first place? It wasn't just about making jackets look cool, was it?
Huh? No, not originally. Not at all. It started way before high fashion got involved. The core idea was really about efficiency, convenience, speed even. Think about what people used before. Buttons. So many buttons, hooks and eyes, laces, miles of laces, snaps. Imagine doing up a pair of tall boots with like 20 tiny buttons every single morning. Tedious, doesn't even cover it.
Oh, man, yeah. Yeah, nightmare.
Exactly. So the first attempt, the patent anyway, was back in 1893. Whitcomb Judson, he called it a class blocker, and it was meant for shoes to make them easier to fasten. It wasn't quite our zipper, though. More like a really complicated hook and eye setup. Kind of clunky.
Okay, so he had the idea, but not quite the final version.
Right. It took another inventor, Gideon Thunback, around 1913, to really nail it. He refined Judson's idea, came up with the interlocking teeth system we know today, called it the separable fastener. His hookless fastener number 2, catchy name, huh?
Yeah.
Was basically the modern zipper.
Hookless fastener note 2, love it. And it's just wild to think how that invention changed everything, from just shoes to clothes, luggage, camping gear, everything that needs closing securely. Seriously, try to imagine life without zippers. How different would things be?
It's a really good thought experiment, actually. Imagine trying to get a truly windproof seal on your winter coat with just buttons flapping around.
Yeah, drafty.
Or trying to quickly close up a heavy backpack full of gear before it starts raining. Laces, fumbling with buckles. The zipper just gave us a fast, reliable, often weather-resistant way to close things. Without it,
Yeah.
yeah, clothes would be less practical, bags less secure. Things like tents, sleeping bags, even spacesuits. They'd be way harder to design and use.
Yeah.
Maybe impossible in some cases.
Yeah, even when they get stuck, which, happens.
Oh, yeah. The dreaded stuck zipper.
Right. But it's usually fixable. It's not like the whole concept is broken. It just shows how reliable they normally are. Okay, so we've got our tech, the zipper. We know how it works, why it's important, but how does it even get made? This brings us to something called systems thinking.
Mm-hmm.
It's not just about the parts of the zipper itself. It's about everything needed to bring it into existence, like a whole web of stuff.
Exactly. It's understanding that everything's connected. People, materials, energy change one thing, and it affects everything else down the line. It's definitely not magic. It's this complex network.
So let's break down that network. Apparently, there are 7 critical resources needed for any technology, including our friend the zipper.
That's right. 7 key ingredients. Let's tick them off. First up, people. Obvious, maybe, but crucial. You've got the inventors, Judson and Sunback, but also the engineers refining it today, the factory workers making the tiny parts, the designers choosing which zipper goes on which product, the people sewing them in, so many people.
Right. Human ingenuity and labor. Got it. What's next?
Number 2, information. This is huge. The original patents, sure, but also all the accumulated knowledge about metals, plastics, mechanics, manufacturing processes, the blueprints, the research. How strong does this need to be? How flexible? What happens if it gets wet? All that know-how. Without it, yeah, we'd be starting from scratch every time.
Okay, people, information. Number 3.
Materials. What's it actually made of? For zippers, that means metals like brass, aluminum, maybe steel for the teeth and slider, chosen for strength or weight or maybe resistance to rust, or plastics nylon, polyester for coil zippers, the ones that look like little spirals, often used in sportswear or bags. And don't forget the fabric tape, usually polyester or cotton blend, the actual stuff the teeth are attached to.
Makes sense. Okay, number 4.
Energy. You need power. Power for the giant presses that stamp out metal teeth.
Oh, yeah.
Power for the injection molding machines that make the plastic parts. Power for the looms weaving the tapes. Power for the assembly lines, the sewing machines, even the lights and computers in the design office. Lots of energy.
Okay, 5. We're getting there.
5 is tools and machines. This is the physical equipment. Those stamping presses we mentioned, molding machines, super precise cutting tools, specialized sewing machines designed just for attaching zippers, maybe even robots on the assembly line. These aren't just hammers and screwdrivers. They're often complex, custom-built machines.
Right. Specialized gear. Number 6. Smells like.
Money.
Yeah.
Capital.
Yeah.
You need funding for the research, for building factories, buying those big machines, buying the raw materials, paying all those people, marketing the products, shipping it around the world. It all costs money. Big investment needed, especially for mass production.
Okay, 1 left. What's number 7?
Time. Think about it. Judson's idea was in the 1890s.
Sure.
Sunback perfected it in the 1910s. But zippers have been constantly improved ever since, making them stronger, smoother, waterproof, even self-healing sometimes. That development takes time, decades, over a century really. Time allows for testing, learning from mistakes, making things better and better.
Wow. People, information, materials, energy, tools and machines, money, and time. That's a lot for just a zipper. So here's a question for you listening. Think about those 7 resources if you had to pick one. Just one. Which do you think is the absolute most critical for the zipper, or maybe for any technology? Why that one? What happens if it suddenly disappears?
For me, maybe information. Like you said, without the knowledge, we're lost. What do you think?
That's a strong contender. Information is definitely foundational, but I might lean towards people, actually, because you need people's ingenuity to use the information, to adapt, to solve problems when things go wrong, like when a material suddenly becomes scarce or expensive.
Good point. The human element.
Yeah, it really shows how interconnected it all is. A problem with energy supply or a lack of skilled workers, it can ripple through the whole system. Makes you appreciate that little zipper even more, right? Totally. Okay, so we've done the deep analysis. We know how it works, why it matters, what it takes to make it. Now, the really fun part. Let's put on our inventor hats. The innovation challenge. If you, listening right now, were tasked with redesigning the zipper, how could you make it better? Let's brainstorm. Could it be safer? Like absolutely pinch-proof.
Ooh, good one. Especially for kids' clothes.
Or maybe designing the pull tab so if it breaks off, it's impossible to be a choking hazard. What about making it cheaper? Like way cheaper, using different materials or processes so it's super accessible everywhere?
Or think green. Sustainability. Could we make a super durable zipper from, say, recycled ocean plastic?
Yeah.
Or plant-based materials?
Yeah.
Or engineer the manufacturing process to use way less energy or water? Those are huge challenges engineers are working on right now.
And what about crazy conditions, extreme environments? Imagine a zipper that absolutely will not jam, ever, even if it's caked in mud or frozen solid with ice.
Oh, that would be amazing for outdoor gear.
Or one you could easily grab and pull even if you're wearing massive, thick winter gloves. No more fumbling. Think skiers, construction workers,
Yeah.
astronauts maybe?
Exactly. And these aren't just, fantasy ideas. This is what engineers do. They look for problems,
Mhm.
for friction points, sometimes literally, and they iterate. We already see things like waterproof zippers, magnetic closures that sort of snap together
Oh,
easily,
yeah, those are cool.
even zippers that can kind of heal themselves if a few teeth get misaligned. You just zip it back and forth. It's all about identifying a need, brainstorming a solution, building it, testing it, refining it, rinse and repeat. That's innovation. Asking what if and how can we?
And there you have it. What a fantastic deep dive today. We started with something totally ordinary, the zipper, and look where we ended up. We've seen the science, the history, the societal impact, the whole complex system behind it. We've used our brains for critical thinking, creative thinking, systems thinking. Pretty good workout.
Absolutely. And the key takeaway here for everyone listening, you're not just someone who uses technology. By thinking like this, asking these kinds of questions, you're stepping into the mindset of a designer, an engineer, an innovator. And honestly, the world needs more people like that. People who can look at everyday stuff and see ways to make it better, solve problems, create something amazing.
Totally agree. So next time you zip up that jacket or your backpack,
Mhm.
maybe just pause for half a second. Appreciate the hidden genius in that simple mechanism. And then ask yourself, what brilliant new version could you dream up? Because the future of innovation, it's not just in fancy labs. It might be right there in your head, sparked by the most ordinary thing. It's in your ideas. Okay, think about this. You probably